Good morning everyone. So welcome back to your maths clinic. So today I'm going to talk about transformation. Yeah, transformation, okay? So transformation is one of the chapter, okay? The most of the question came out in paper 2, okay? Most of the time now, paper 2. Most of the time is paper 2. Yeah, so you need to like strengthen yourself, do more exercise because sometimes their question is very tricky and it's kind of complicated. So it's actually not that complicated. Just do more and you understand more. Yeah, so let's start. Okay, so first question, 1A. Okay, so here are those infos of the transformation. Yeah, so translation, we have reflection, and we have rotation. So let's start the first one. So find the coordinate of the image point of 1, 5. Okay, so 1, 5. So the first one, he wants us to find transformation P. So P is a reflection in line y equals to 3. So y equals to 3 means the line is over here. Yeah, this one. See that, see that? You can see my line, right? I just use a fine, just blue line, okay? It's more easier. It's visible. Easy to visible. It's visible, yeah, visible. So this line, okay? So reflection on here. So your coordinate is on this one. And then when you reflect, right, you just calculate distance from your point to the line. So it's over here, here. So it's 2 blocks. So when you reflect over in that, when you reflect, right, it goes over here. Yeah. So the point is 1, 1. So just write 1, 1. Okay. So the next one, okay, transformation R is, okay, the rotation of 180 about the center for 1. The rotation means you need to rotate it, but basically if you rotate it, right, 180 is like the opposite side. It's something like mirror, but I cannot say it's mirror, so just, yeah, be careful. Okay, rotation 180 about the center for 1. For 1, it's over here. Yeah, it's over here. So, okay, let's rub it first since, okay, this line we still need it because you see, third question over here, we still have the transformation P, so I don't want to rub this line. So it's over here for 1, and then rotate it. Yeah, so you rotate 180 degree. Basically, it's on the opposite side. It's like over, let's see, where was it? Okay, just draw a line out. And then it's, you see this, I explained to you why, okay? So, why was it like this? Okay, if I like draw a square over here, right? Because you rotate 180 degree ma. Okay, so yeah, you see these two square over here, yeah. So when you reflect, no reflect, okay, rotate 100 degrees from this center. Maybe I should draw a smaller one, okay, over here, smaller one. You rotate 100 degrees, like, should I just erase this first? Okay, so let's draw again. So smaller square over here, it's easier to see, right? So you just rotate 180 degrees. So you come over here. Yeah. So you get the answer. So from here, your point is over here. That means if you rotate 180 degrees to another side, right, the point must be over here. Okay, this, you know what, this diagram I just use as a reference, because if I don't use as a reference, right, it's harder, it makes really complicated for me to explain how do I get the answer. So the answer over here is, okay, see, 7 and 3. Okay, 7 and 3. Okay, 7 and 3. Oh my gosh, my handwriting. Never mind. Let's write again. Okay, so last one, transformation PT. So basically, if you read this, the only thing you need to know is you read from outside to inside. So it starts from T first. You always read from outside to inside, okay? So transformation T is translation, -6, 2. This is the x-axis, and this is the y-axis. So your point, okay, let's rub it. Okay, don't rub the straight lines because we have some use for it later. Okay, this one can just rub it. Okay, so start from T. T is the translation, -6, 2. This is the x-axis. If it shows that the value is negative, right? Negative, you go to left. If positive, you go to right. It was the same as your axis. Negative value, you always on the left, and the positive one, you always go on the right. If y exists, positive, you go up, negative, you go down. So, okay, so -6 translation. So x-axis and y-axis. -6 is the x-axis. So the points start from this 1, 5. Okay, yeah, it's 1, 5 over here. So you go -6. That means you move left to 6 blocks. Move to the left side. So just like 1, 2, 3, 4, 5, 6. Yeah, is it 6 block? Okay, 1, 2, 3, 4, 5, 6. Yes, 6 blocks. And then you go up. Y, you go up. Okay, go up 2. So 1, 2. Okay, and then it comes over here. So I just write it down. This is 6, and then 6 is 2. You come to here. Okay, it's not the end, but you still have to write the coordinate for this one first, T. So the coordinate of T is, okay, -5, and then what's this? -5 and 7. Is it 7? Okay, it's 7. Okay, so and then you draw an arrow out because you still have a transformation over here. Okay, P. Next one is P. So the reflection in the line y equals to 3. So it's over here. Okay, it's over here, and then the point is here. So the distance from your y-axis to the reflection line is 1, 2, 3, 4. So come over here, and then you reflect over there. It's still the same. The distance is 1, 2, 3, 4. That means the answer is, yeah, -5, -1. Okay, yeah, we are done. That's all. So let's continue the next questions. I need to erase it because you see, next question over here, it's related to the shape over here. Okay, let's wrap it first. So PTUV is the image of EFGH. So, okay, this big one is the image of this one. So, erase it first. Okay, so describe it in the full transformation. So you see this one under combined transformation MN. but you need to read, yeah, just like I told you, read from the right side to the left side, from the outside to the inside. So N, it starts with M first. So let's see. It is really obvious because it's a rotation over here, because if it's reflection, right, it's like thing shown in the mirror, but this is not the thing shown in the mirror, right? Okay, it's not on the same, how do we say that, it's like not the right reflection, so that this is not a reflection. Okay, it's not enlargement, but later here is the enlargement. Okay, this is rotation. So you say this rotation, it's like it lays down and then it went up. That means it's a clockwise rotation. So basically it's 90-degree. How do you know that? Because I just told before, if it's 180-degree over here, it will be like the opposite side. Like if the center is here, right, it should be here. So this is not 180-degree, that means it's 90 degrees. So basically you just find the rotation point. Okay, you will get something like a right angle, that means 90-degree. The center, find the center. Okay, just see this, it's from here to here, it's a clockwise. If it's from here to here, it's an anti-clockwise. Different situation, different answer. This is a clockwise rotation. So let's see where's the rotation. Okay, 0. It's probably like, okay, I think it's here. Where was it? 0, it must be 0 and -1. Yeah, it's over here. I draw it out. Okay. It's like here, then you here. Okay, then you see, this is a right angle, 90 degrees. Yeah, you see this? And then just connect it. Okay, you connect, like you see this one, PTUV is the image of this one, PTUV over here. So if it doesn't undergo an enlargement, it's over here. So you see this one, F equals to Q, E equals to V. So you just like connect it, and then you just make sure it is right angle, means 90 degrees. Yeah, I know it's really, yeah. Fine, just rub it. It's really annoying because complicated lines all stuck together. So just point it here. So how do you write this? Okay, this is a bit, okay. Can I just make it smaller or something else? Fine. It's a rotation. Sorry. So my writing style is like this one, 90-degree. Remember to put that degree. Okay, I'm not sure where's my degree. Fine, I cannot check the degree, the symbol of degree over there, so I just put 90. I just put degree, but don't write degree. Okay, let's write that thing, that symbol, something like the full stop in Chinese, but it's like the upside here, the 90 degree over here. So rotation at the center. So where's this? You just read it from here. At the center, 0, 1. So 0 and then 1. Yeah, that's all. Yeah, move it up so later it's easy for me to write for the M. So basically, this is, yes, 90-degree rotation. Okay, so I just continue. The center, 0, 1. This is my, oh, sorry, I missed out something. Okay. you need to mention it is clockwise or anti-clockwise. Oh my gosh, it's so big. Let's see if I could make it smaller. It's really annoying, but never mind. Okay, let's continue. Okay, so just write this, okay? 90-degree clockwise rotation at the center, 0, 1. 0, -1. Sorry. Let's see, it's over here. Okay, good. Let's. Okay. So the next one is M. You undergo rotation and then you undergo an enlargement. So basically, if you see this, you need to see where is the enlargement. Where is the image after the enlargement? So this one, PTUV is the enlargement. After enlargement, the image undergo enlargement. That means this one is a shape under enlargement. This one, PTUV. So this is the object. This is also an object, but it just undergo rotation, okay? So this is the image. So for here, B, you need to find M. Where's the enlargement point? You just know how to do it. Just draw a straight line where the image after the enlargement, like, okay, I make an example like this. You draw a straight lines over here, just like this. Okay, so after all, right, you draw all these things over here. You will actually realize that all the points like connected to the points of the object has the same center. It all accumulate over here. Yeah, that means this center is the center of enlargement. But you don't write center of enlargement, okay? So how do you write this? Okay, let's start first. Where's the, okay. So you write this one. Okay, let me think. How do I write it out? So, okay, this is my way of writing it. So I always remember enlargement on the scale factor. So how do you know the scale factor? So basically, scale factor, what's that? No, sorry. Yeah, scale factor. Okay, scale factor from this one to this one. This is the object, okay? No, this is the image. This big one is the image, and then it's the object. So erase it first. How do you determine the scale factor? Scale factor, basically, it's like, you see this? Okay, I just make this one. This is a triangle. After enlargement, it becomes like, you saw this one? It becomes 2 times bigger. If 3 times bigger, it's like this. Yeah, it's like this. If 3 times bigger, it's like this. So this is 2 times. It's over here only. But honestly, it can be any enlargement scale factor because it can be small and it can be big. If it's small, like if it's like small, right? Okay, use this as an example. So from the big triangle over here, no, not triangle, sorry, the image, okay, not triangle. So if it's like from this big one become this small one, yeah, it could be anything can happen in trial. I mean, you have a trial already, so never mind. So just prepare for your SPM. So from this big object, this big image to this object means that its scale factor, it's like 1/2 because it's half of the size of the big one. See this is twice of the size of the small triangle over here, and then so if it's from this one become this one is 1 over 2, but if it's from the small one to the big one, just write 2. So on a scale factor 2, yeah, just now I mentioned all the lines accumulates in this one, and this one. So all accumulate on here. So just write it. Yeah, it's a bit okay. So I just mark it out. It's over here, the enlargement center. So on the scale factor 2, at the center, you can actually write the alphabet P. But if you write the alphabet P, right, you need to mention what is the P coordinate. Like this one, P coordinate is like 2 and then 1. Okay, hope you guys understand why it is 2, 1, because yeah, connect it. So it's 2, 1. Okay, so here's the answer. Yeah, I know the space is really spaceless, but never mind. So I just put it over here because yeah, it is B1A and B. So the last question. Okay, this is not as hard as I think. So he wants us to find the trapezium. Yeah, this is the trapezium PTUV. A trapezium represent a region of area. Okay, so I drew it out first. I know it's a bit never mind. I just rub it and draw it again. So it's over here, then here, and then here, and then here. I know it's really ugly, but never mind. I just make an example. Here, 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 and then here. This is a big one. This is a small one. This big area, you see this one? PTUV. I just label it out first. PTUV. So the area of this one is 54.4. Is it okay? Centimeter. Okay. So he wants us to find the area of the shaded region. It's this one. This one, okay? I can say it's a polygon, yeah. But never mind. I know it's really ugly. I won't wrap it first. Okay, so let's continue. So he wants us to find this one. So before that, you have to find the area of the smaller trapezium. Do you know what is it? So the formula is, so our original formula is like, okay, where should I write it? It's right over here, okay? Formula is like area of object multiple, just put x, okay? Multiple by the scale factor. The scale factor, so just now I did mention, right? It's 2. So here, yeah, it's 2. So, but the thing you know is like, and then the square root, no, that's not the square root, it's the square of the scale factor. Okay, scale factor, the square of the scale factor, and then you get the area of image. So the info give you the area of image already. So basically you just this is kind of annoying, but never mind. The area of image, okay, it's given, it's 54.4. So before that, you have to find the area of object, and then you use the big one minus the small one, and then you get the shaded region. Yeah, that's all only. So let's find the area of object. So the square of the skew factor. So the square of the 2, it's 4. So that means I just write abbreviation, okay? Area of object equals to this is area of object equals to 54.4, then just divided. I just use the dash, it represents divide. So the square root of the square of 2 is 4. So basically the area of object is, let's use my calculator. So it's 54.4 divided by 4, so it's 13.6 over here. So yeah, this is cm square, okay? Remember, cm square, okay? And then it wants to find the shadow region, just like I mentioned just now. You just use the image, and then just minus, subtract the area of object. So it equals to, so 13, no, 54.4 is a large trapezium, and then the small one, the object, is 30.6. So you just use 54.4 and then minus by 13.6. So you will get the answer. So where's my calculator again? So 30.6, it's 40.8. Yeah, well done. We done the whole question over here. So yeah, if you do more exercises, you will like master it. Honestly, it's not that hard actually. Everything over here is just, I cannot say it's easy as a piece of cake, because even though when someone get full marks in maths, doesn't mean he stopped himself at 100 marks, because he or she can do better. So you just do more exercises. Anything can happen and any question can come out. Okay, you can't predict it or estimate the question. I can say it's like 没有一定的筹数. That means it can be any question. So this is one of, not too hard but not too easy. So yeah, and this is the class for today, and see you guys in the next video. Bye.